Welcome. In this video we'll be discussing about the matrix multiplication operation using 8085 microprocessor. We'll be assuming two n cross n matrices. Let us say we have a matrix A having elements A11, A12, so on, A1n. So this there will be n cross n number of elements in the A matrix. Similarly, we have another matrix B having the elements B11, B12, so on up to Bn. Again, n rows, n columns make up n cross n number of elements. The resultant matrix C will also be having n cross n number of elements, and these elements will be C11, C12, so on up to Cnn. I'll not be discussing the matrix multiplication operation here, how we actually obtain the matrix multiplication operation. I'm assuming that you are well aware about that. So in order to perform this operation, that is, we want to basically be able to multiply two matrices using the 8085 microprocessor. What we'll be doing first is we'll be loading all our prerequisites into the memory space. So we'll be loading the matrices in the memory space. We have first the A matrix. What we'll be doing is we'll be loading the A matrix from 2501 up to 2501 plus n cross n, in that will be whatever is the order of n matrix. So A11 goes at 2501, A12 goes at 2502, A1n goes at 2501 plus n, and so on. So your last element, that is A and n, will be going at 2500 plus n square. And for the matrix B, what we'll be doing is, instead of entering the elements row wise, we'll be entering the elements column wise. That means we'll be entering B11 at memory space 4501, and then we'll be entering B21 at 4502 rather than B12 in this particular case. Similarly, then B31 will be going at 4503, and so on up to BN1, which will be going at 4500 plus n. And then we'll be having B12 that will be going at 4501 plus n, and so on. The resultant matrix C will be stored at 6501 and beyond. So C11 will go at C11 will go at 6501, C12 will go at 6502. This is not something that will be entering. This will be the result that will be generated. So the memory spaces that we are allocating for the result is 6501 and beyond. So we have entered first the matrices, matrix A and matrix B. Both are n cross n matrices. If the order of the two matrices, let's say for example matrix A has an order of m cross n, then the order of second matrix has to be n cross something. Fine. So this needs to be there. That means the column of one matrix has to match with the row number of rows of the another matrix for matrix multiplication to take place. Now since both of these are square matrices, so we have n cross n A matrix, we have n cross n B matrix, the resultant matrix C will also be n cross n. So it will also be occupying n square number of memory spaces. So in short, we are loading matrix A at 2501 and beyond. We are loading matrix B at 4501 and beyond, and the resultant matrix will be stored at 6501 and beyond. This was one thing that we were allocating. We'll be initializing some more memory locations with the data, and what will be the data here at 8000 and at 8001, and similarly at 8002 and 8003. These are the memory spaces. We are loading 0125 to 0125 again. So it's actually nothing but 2501. It's actually the address. And 9001 we are loading 01 and 4501 is actually the address of matrix B. 9500 and 9501 we are loading 01 and 6501 is nothing but the memory address of the resultant matrix C. Fine. So 8000 to 8003 is pointing just towards the memory location. Where matrix A is stored. 9000 and 9001 is simply pointing towards the memory location where matrix B is stored, and 9500 and 9501 is carrying 6501, which is pointing towards the memory location where the matrix C will be stored. So these were all the data that we will be first of all initializing in these memory locations. We can directly feed them into these memory locations before execution of the program, or we can make them a part of a program and simply transfer these data to these memory locations simply transfer these data to these memory locations. Now heading towards the main program, we can first have a look at the flowchart of this program. We're initializing the data. These will be the matrices and the data as previously shown. We need to load the value of n. That is actually the order of the matrix. This n can be stored at some memory locations or in some registers. Say for example, at register, we are storing n at in E as well as in C register. Now we'll be loading the elements of matrix A and B in any two registers. Say for example, we are loading them at in the accumulator as well as in the B register. Then we know the normal operation of the matrices will be multiplying them. We'll be multiplying those two elements, and we'll be adding the result of their multiplications, and we'll be adding the result of their multiplication operation to 6501. 6501, as you already know, is the location where you'll be storing the resultant matrix C. At 6501, what we'll be seeing is we'll be having C11 plus A12 into B21 plus A13 into B31, so on. So what we are doing is we are first multiplying A11 and B11 and adding that to 6501. So initially assuming that at 6501 there was 0, so to 6501 we are adding A11 B11. Then we'll decrement the value 0. We'll be going back and loading another element of matrix A and B, that is A12 and B21. We'll be multiplying them and we'll be adding this result back to 6501. Again decrement the value of n. At this location you might have seen that I have written add this result. At this location you might have seen that I have written add this result to 6501 plus some number. What this number will be is it will be actually 0 initially, but with every counter that with every loop that will be running, this number will increment. Fine. So initially it is at 6501, so we are multiplying A11 B11 adding it, multiplying A11 B11 adding it to 6501. We are multiplying A12 multiplying B21 adding it to 6501, A13 B31 adding it to 6501, A1n BN1. We are multiplying those two numbers, adding that to 6501. We have not yet done anything with the D register. Fine. That's D register. Fine. That's actually carrying 0 initially. Once this operation takes place, we'll check the status of 0 flag. Once it becomes 0, will be now incrementing and selecting another column of B matrix while keeping the same row of A matrix. We are now trying to B21 plus A12 into B22 plus A13 into B23, so on. So like this we'll be obtaining the second operation, and in between this what we have to do is we have to actually load the value of n again into the system, so that this operation takes place again n number of times simultaneously. What we are doing is now we are incrementing the D register so that this is 502 instead of being stored at 6501. Fine. So this will also take place n number of times. So once this operation finishes, we'll be decrementing E register, checking the status of 0 flag, and then we'll be incrementing now the row of matrix A also. So first we'll keep the same row of matrix A while keeping on changing the columns of matrix B, so that we can obtain C11, C12, C13 up to C1n. So once that is done, we need to now obtain C21. So for that we need to now shift and resetting the column of matrix B. So we'll be resetting the column of matrix B and incrementing the row of matrix A. We'll be selecting the second row of matrix A and selecting the first column of matrix B, and this operation will now take place n cross n number of times. Finally it will become 0, and this whole will actually at the end yield our result, that is matrix C. So once this is done, our operation will finish. So now coming to the main program, so this is a simple uh, program, a simple instruction. We are simply moving the n to accumulator A. We are simply moving the n to accumulator A. We are storing this n at 2400. We are storing this at 2402. We are also storing this at 2401. Here what we are doing is we are loading the accumulator back with we are loading the accumulator with the contents of 2. Fine. So the what why we need to do this, it will be clear as we move ahead in this program. And then we are also storing this n at 2403. So these 5-6 instructions that we have written, what we have done is we have simply moved n to A and then stored that n at 2400. 240 is we are again loading accumulator with 2402. So this will be actually used in a counter, in a loop that will be actually seeing ahead. Fine. So once we do this, now we are we know at 9000, if you remember, if you remember, at 8000, at 9000 and at 9500 we had given some data. At 9000 we had written 01 and 9001 we had written 45. So using the instruction LHLD 9000, what we are doing is we are loading the 9000. What we are doing is we are loading the contents of 9000 to L and loading the content of 9001 to H. That means in H register pair we are moving 4501. So 4501 is actually the address where memory matrix B is stored. So these two instructions, move D comma H, move E comma L, instead of writing move D comma H and move E comma L, what we can do is we can simply write exchange. It will exchange the contents of HL with D register pair. Or what you can also do is you can simply move the content of H to D and move the content of L to E. So we are moving 4501 actually to DE register pair in short. Again we are tapping LHLD 8002 and 8003 again carry 2501. So we are loading 2501 into HL register pair. That is actually carrying the address of matrix A, where we have actually stored matrix A. At 4501 we have stored matrix A. So in DE we have 4501, in HL we have 2501. Now using this command LDXD, whatever was in the DE register pair, it's actually whatever was in the DE register pair, it is actually carrying the memory location, and the contents of that memory location, that 4501, will be loaded into the accumulator. So the contents of 4501 are loaded into the accumulator using LDX instruction, and that content of accumulator is now transferred to B register. And the content of M, that is actually HL register pair, it's pointing towards memory location 2501. The contents of that memory location are being transferred to register C. So what we have done is we have at 4501, that is matrix B, we have transferred that to B register pair. At 2501, that is the contents of B register pair. So we have the element of matrix A, we have the element of matrix B stored in C and B register respectively. So using this instruction, so now we are resetting the accumulator A and transferring 00 to the accumulator A. We have to simply multiply the contents of 2501 and 4501 that are stored in the C and B registers. Next few instruction is simply the program that we write for multiplication. MVI A00, add C, decrement B, GNZ loop 1, where loop 1 add C, decrement B, GNZ loop 1, where loop 1 is pointing towards the address of add C. So this will simply add the contents of 2501 and 4501 in the first instance. Fine. So that's actually the being multiplied with each other. So once this is done, we can move the content of this content is actually being stored in a accumulator. We are now saving it in the C register. SHLD 8000 So if you remember again, at 8000 and at 8001, the same is actually already available in the HL register pair. So we are trying to send that back to 8000 and 8001. So using this instruction, we are now saving the contents of HL register pair at 8000 and at 8001. While as the contents of L will be stored at 8000, the contents of H will be stored at 8001. And then we are loading the contents of LHLD 9500. That means 9500 carries 01, 9501 carries 65. So 6501 is being transferred to HL register pair. This is actually the location where we need to now actually store the result. Fine. So our result for the time being is temporarily being stored in the register C. So we are first loading this register HL register pair with the content where we need to store the address where we need to actually store the contents. So using move a comma m, now what we are doing is whatever was stored in the HL register pair, that is actually 6501, initially it will be carrying 00, it is being transferred to A. We'll simply add C to it. Fine. Taking the data from 6501 and adding uh, the contents of C to it. Fine. So every iteration this will keep on taking place. So in the first iteration it was initially carrying 0, so we are adding A11 B1 to it, B11 to it. Fine. Then we'll be adding carrying A11 B11, so we'll be adding A12 B21 to it, then we'll be adding A13 B31 to it, so on up to A1 and Bn1. And similarly we'll be doing the same operation then while adding while transferring the storing the data at 6502 6503 and so on, storing the data at 6502 6503 and so on. So once we add this content of C, transfer it back to the HL register pair, and whatever was in the HL register pair, we are storing that back at 9500. And now loading back LD 8000, that's actually the address 2500. Why we need to do this is because we need to now increment this address. We need to be pointing towards the next element of our matrix. So we are incrementing it. We are incrementing the HL register pair by 1. Initially we were having A11 and B11. We have multiplied those two. Now we need to get A12 and B21. So for that we need to increment both the HL register pair as well as the DE register pair. So we incremented both HL and DE register pair, and once we do this, we can again fetch the data from those two memory locations and keep on storing this. Fine. So what we are here doing, we are loading the content of 2402. 2402, as you remember, is carrying actually n, so we are loading it into the accumulator. We'll be decrementing it so that our first iteration is actually completed, and we'll be storing this back at 2402 once after decrementing it. And now I'll be checking the condition for J and Z. If while decrementing A, if our 0 flag is not set, it will jump back to loop number 2. But if 0 was set, if 0 is obtained, then it will keep on moving ahead. Fine. So loop 2 is nothing but LDAXD. We are again getting the content of DE register pair, we are getting the content of HL register pair, after incrementing them, loading them back into B and C register, multiplying that, and in the process do this. This will be done n number of times. Now again we are loading 2400. As you remember, 2400 is also containing n, and we are storing this in 2402. Fine. So once actually the upper loop finishes, 2402 will eventually be carrying 0 instead of n. 2402 will eventually be carrying 0 instead of n. So what we need to do is we need to reset, we need to make sure that it is again carrying n. So we are loading the content from we are loading LDA 2400, or what we can do is we can simply move n to 2. Instead of doing this operation, we can simply move the n to 2402 if we already know what is the value of n. Also we need to now increment 6501 to 6502. So for that, first get 9500. So for that, first get 9500, get 6501 from 9500 using the LHLD instruction, increment that, and then store it back at 9500. So what we have done using these instructions is that 65 we have incremented 65 towards 6502. In the next iteration, what will happen is that once we perform the next multiplication operation, the result will be stored at 6502. Now in between this, what we have to do is we'll be keeping the same, we'll be having the same row of matrix A, but we'll be now taking the second column of matrix B. Fine. So load again 2403, decrement it and store it at 2403. Check for if it is not equal to 0, it will jump back to loop number 3, that's LHLD 8002, and then the second iteration takes place. So in this iteration, what is happening is that we are keeping the same row of matrix A, but we are keeping the same row of matrix A, but we are moving to the next column of matrix B, then the third column of matrix B, until we have the nth column of matrix B multiplied with the first row of matrix A, and this result will be stored at 6500, 6501, 6502, so on up to 6501, 6500 plus n. Fine. So we are actually storing C11, C12, C13, so on up to C1n. So this completes that operation. Again loading, so what we are doing here now is we are loading the contents of 8000. Fine, and we are moving that to register C. We are adding the content of, we are moving the content of, we have first loaded 8002 with the 8002 is actually basically carrying 2501. Fine. So I moved that 01 to actually accumulator A, and then eventually to C, and now we are moving 2402, that's actually carrying N into accumulator A, and we are adding that to C, so that 2501 points now towards 2501 plus N. Right, that means actually it is pointing towards the next row of it's pointing towards the next row of a matrix. Eventually we are again storing this at 8002 and also loading the accumulator with the contents of 2401, which is carrying nothing but n, decrementing it, this is 0 or not. So this will take place again n number of times, n cross n number of times, and this multiplication will finally finish. So this is the complete program of matrix multiplication. You can try to refine it. As I have said, there may be some instructions that can not be necessary to be used in this fashion, but this will eventually help. One more thing I want to just point out towards the end, once we were adding the content, once 2501, we're pointing it out towards 25 plus n, 2501 plus n cross n. So in this process, what you have to do is you have to make sure that you also multiply 25 with the carry that will be generated as a result of this addition operation. So that I have not included here, but you can use that in your program. So this finishes our matrix multiplication using the 8085 microprocessor. If you like the content of this video, you can share it, and if there are any queries, you can post that in the comment section.